Welcome to the Discover Engineering and Turn Your Ideas into Reality video and webinar series brought to you by Siemens. My name is Feroz Shahid. I am the ASME Director for Student and Early Career Programming. Today we'll be talking to Ashley Kimbel, who's currently a student at the University of Alabama at Birmingham, where she studies biomedical engineering and chemistry as part of a pre-medical track. Today we'll be talking to Ashley about what's so cool about engineering. So Ashley, welcome. Thank you for joining us.
Hi, Sarosh. It's great to be here.
Thank you. We're excited to have you. So Ashley, why don't we start by, if you could, just tell us a little bit about yourself.
Well, my name is Ashley, and I'm a junior at the University of Alabama at Birmingham. Go Blazers. I'm majoring in biomedical engineering with a minor in chemistry. As you said, I hope to go on one day and become an orthopedic surgeon. I grew up in Huntsville, Alabama, with two parents who are also engineers and two younger sisters and two little dogs.
How were you introduced to engineering?
That's a funny story. So like I said before, I have two parents that are engineers. My mom is an electrical/software engineer, and my dad is a trained aerospace and mechanical engineer. But I would see them working on this stuff, and I always thought I would never want to be an engineer because I don't want to do this. But then when I was in 7th grade, I was in this pre-algebra class, and I had this teacher named Drew Sparks, who was starting the very first green power team in the United States. And for people that don't know what green power is an electric car competition for young middle to high school age students, where you actually get to build an electric race car and then go race it against other teams. And through that program, I fell in love with engineering. I fell in love with the process of having an idea and then getting to take that idea from your head to what I call like a napkin, like, just like a sketch of some kind, and then to like ultimately 3D digital design. And then eventually, you get to actually make it, and you get to feel it, touch it. And at the beginning of high school, part of being in green power was being in this advanced manufacturing program. But through that program, I learned solid edge modeling, which is through Siemens. It's a free software that you can download. You can create almost anything in your brain, put it on the computer, and build it. Yeah.
Was there anything that you did in high school, apart from the project you described, that really solidified your focus and interest in engineering or even biomedical engineering?
Absolutely. There was one main project that I did that really showed me what I wanted my future to look like. There was one of our mentors in the Green Power program. His name was Devin Bain. Had a little brother who lost his leg overseas while he was defending his base. And he's a very active person, loved to snowboard and mountain bike. And when he lost his leg, he couldn't do any of that anymore. And so Devin and I knew each other through the Green Power program. And he kind of knew that I was interested in biomedical engineering because I had always been interested in medicine. And then I had kind of formed this new love for engineering, but I didn't quite know how those two fit together yet. And I was kind of torn between, what do I want to do with my life? And then here comes Kendall Bain, who says, hey, I have this really heavy prosthetic foot that I use for, these high intensity activities, but it's so heavy that I don't know how to, or I tire quickly and I don't know how to keep my endurance up. So I had this new project to design a better high intensity prosthetic foot for him that was light and he could use. And I was able to do all of that through the advanced manufacturing program and all of the resources that I had available to me. Primarily, I used Siemens solid edge software. We took his original foot, scrapped it into its individual parts, built it in solid edge so that we could see what we were originally working with. We had all the specs for how much it weighed, volumes. We could perform stress tests on it through solid edge, through their simulations. And then we were able to take all of that data and we were able to design something new out of a different material. We were using carbon fiber that was donated by NASA to create a new foot for him.
I do want to ask, just related to that, when was that light bulb moment for you as you were working even on this project you just described? What what said to you, this is really cool. This is what I want to do with my career or even in the future?
I would say that light bulb moment for me was actually when we were on the track with Kendall about to test that foot for the very first time. And we had been on a deadline and we did not know if that foot was going to work. We really didn't. And there had been so much failure involved with that foot. I mean, when we were laying up the carbon fiber, we went through, gosh, 3 or 4 times of just failure after failure after failure.
Yeah.
When we were designing it, it was failure after failure after failure. And after a while, especially being new to engineering, you start to get kind of, it's kind of like a negative mindset. Like, I mean, it failed so many times. How in the world is it going to work? But, we pushed through and we just kind of came up with the best thing that we could on the deadline that we had. And when we went to go test it for the first time, he put it on and he said, first thing he said was, "You got the height right." That was before he'd run on it or put any weight on it. But
Yeah.
just the fact that we gotten the height right, I was like, oh my gosh, something worked.
Yeah.
That was one of those light bulb moments for me.
That's amazing. So what's it like being a student at the University of Alabama? Can you talk a little bit about your experience so far?
Yeah, I can. It's a lot of fun. It's very different from what I expected coming into engineering school. I came in expecting to not know a thing. And there's a lot of imposter syndrome associated with that. For me, there was at least. It's like, am I good enough to be an engineering student? Am I not good enough to be an engineering student? And what's very different about UAB, I think, is that because we're so close to a hospital, classes where you start off building paper airplanes, something that everybody knows how to do, and then they slowly build up over time to things that are more complicated. Like I've got a class right now where we're building like EKGs. It is a very hands-on program. It is, we're going to send you to these classes, but we don't want you to just go to class. So a part of your class is going to be going into these hospitals, finding a problem, solving the problem, and then manufacturing something that solves that problem, manufacturing what you design. And so from like your freshman year to your senior year, you really get like that interaction with engineering throughout your entire experience, opposed to just 4 years of school and then just get thrown into engineering. So that's what I love about it.
That's great. And as you were talking, what I would love to learn more about is, as you think about people who are just starting to think about engineering, maybe they're in middle school, maybe they're in high school, or maybe they're in college, right? But what advice would you give young and aspiring engineers who are interested in the field?
Looking back on my last couple of years in engineering school, there are so many things that I wish I had known coming in. And the biggest thing for me is probably follow what you are interested in. Engineering school does not teach you how to be an engineer. It doesn't teach you everything in the world you're going to know to be an engineer. It doesn't even teach you a quarter of what you're going to know to be an engineer. But what it does do is it teaches you how to think like an engineer. It teaches you how to learn from failure, because that's what engineering is. We don't learn anything by just building something, it works, oh cool, that worked, and moving on, because that rarely ever happens. All of our learning comes from, well, these 52 different ways of doing it didn't work. So what is now going to work? You have to learn how to learn through all of your failures. And that's what engineering school teaches you. So that I would say, get used to that. But also don't be afraid of failure. Everybody comes in expecting to fail. But one of the great things I think about engineering school is that it is, and this is something truly unique about engineering school, I think, is that it is community-based. There has never been an engineering class that I have taken where I did not work with everybody around me. Because even when you get into industry, or if you don't go to industry, you stay in academia, everything in engineering is team-based. And so all of your engineering classes are team-based. And that is I just think that's something so special about it because there is nothing like struggling through something very difficult with other people. The only thing you need to be an engineer is passion for engineering and curiosity for engineering and the ability to ask questions that allow you to follow paths that are going to take you to areas where you thrive in.
Absolutely. Well, Ashley, I just wanted to say thank you. It was great talking to you today and learning more about your passion for engineering. We look forward to hearing and seeing from you in the future and see what you have ahead of you. Again, thank you to Siemens for sponsoring this Discover Engineering and Turn Your Ideas into Reality video and webinar series.